Okay, so there are three main ways that glaciers move. This is basal slip, regelation creep, and internal deformation, and today I'm going to teach you how those work. So, we start with basal slip. Basal slip is where you have glacier, like so. Let's say this is the glacier, and basically, let's have it extend up there. Basically, in this glacier, there is some meltwater. And this meltwater is in a subglacial, which means it's beneath the glacier. And if it's beneath the glacier, it will be in between the glacier and the bedrock. And because the meltwater is between the glacier and the bedrock, it means that there's reduced friction because it acts as a lubricant. Now, when there's reduced friction, this means that the glacier can slide along the bedrock a lot quicker than it would usually be able to. So, in temperate glaciers, which are glaciers that exist in areas of high altitude, there is much more meltwater because average temperatures annually in the area are a lot higher. So meltwater is able to exist in much larger quantities, meaning that basal slip is much more prevalent, it occurs much more in temperate areas. Okay. However, if you have a cold-based glacier, so a glacier such as that of an ice sheet in Antarctica, there will be a lot less meltwater. So there might be a little bit here and a little bit there because, well, really there's not much melting when temperatures are way below 0 degrees. Okay. So basal slip does not happen as much in these areas of cold-based glaciers. All right. Next, we go to regelation creep. So regelation creep is where you have your glacier, all right? And inside the glacier, so for example, when it reaches a obstacle, so you have your glacier and it's moving this way, let's say, and let's say it's met a little kind of hill, for example, or like a rock, a massive boulder. What happens is in this area here, at the base of the glacier, this glacier can't physically crush through the rock without needing to erode it, which will take a long period of time, but the rest of the glacier is pushing it forwards, it's trying to get past this rock. So what happens is pressure builds up here, meaning that meltwater forms, because as pressure builds up, heat builds up. Pressure and friction means heat, right? So heat causes meltwater to form, and as the meltwater forms, it finds ways around the rock, and when it gets around the rock, right, pressure falls very quickly, and because outside temperatures are so cold and the pressure's fallen, that means that basically it will refreeze. The water will refreeze, right? And the water here refreezes, forming sort of a bit of ice on the other side, and as the rest of the glacier moves over, that's basically how it moves around the obstacle. This is the process of regelation creep. It's the movement of water around. Well, it's the melting of glacial ice when it reaches an obstacle as the glacier is advancing, and it's the refreezing on the other side of that obstacle. Okay. So next we're going to do internal deformation. So internal deformation is a bit more of a sort of, I would say, less prevalent. It doesn't. It's a smaller kind of process, but it's equally as important. Okay, so what internal deformation is you have your glacier, all right. Let's say it's actually traveling downhill at a slight slope. You have your glacier here, and let's say maybe it's cold based, so it's not really experiencing much basal slip because it doesn't have enough melting, and maybe it's not experiencing regelation creep because there's no obstacle. So what happens is if temperatures are around zero, or if temperatures are below, just below zero, there will basically be crystals. So these are really small bits of ice in front of the glacier or around the glacier that keep melting and refreezing because of fluctuation of temperature. And so when these melt and refreeze, they get pushed, they advance a little bit, they advance bit by bit, and this is basically a really small process of how the glacial ice moves. Um, it's accelerated by meltwater because as meltwater sort of interacts with it, right? As meltwater rushes down the glacier at high speeds, um, it brings along the little crystals with it, and this meltwater freezes down. This meltwater might freeze down here, it might not, and the crystals might as well. So you end up with a bunch of ice down here. Okay, um, and so these sort of crystals can also travel solely because of gravity. So if you have a really steep slope, the glacier might not be moving as quick because, well, it's a really large chunk of ice. It's going to take a while, okay? Maybe that's a little too steep, but these crystals will fall really quickly due to gravity. They will tumble a lot quicker than the glacier can move. So it's a way of the glacier sort of advancing bit by bit without the entire chunk of ice moving. Furthermore, I honestly can't remember if I explained. Actually, I did, but wind will push it as well as gravity. So these little crystals can sort of move. There's loads of little crystals that move really fast, and further, they eventually recollect and sort of become actual chunks of ice rather than the little crystals. Okay, and these are basically the three main processes of how glaciers move.